Hello there, and welcome to today's talk. The title of the talk is Amazon EKS Anywhere to EKS Communication with Gloo Mesh. I'm Jonah Jones. I work at AWS. I was a container solutions architect for the past 2.5 years. Currently, I'm an SDE on the EKS Anywhere team. I'm also a maintainer of the CNCF project Falco Security, which is an incubating project. That's my GitHub and that's my Twitter. So I will be covering some of the slides today for today's talk. We also have Lawrence, who's going to be giving today's demo. Lawrence is a field engineer at solo.io for the past 2 years, and that is his GitHub. And that will also be where you'll find the link to the demo at the end of the talk today. So I'm going to quickly go over our agenda, just so you have an idea of how today's talk will be structured. It's roughly going to be about 35 to 40 minutes. We're going to start off with an overview of what EKS Anywhere is, why we might care to have cross communication with EKS Anywhere to EKS, and why that's useful for the on-prem to public cloud communication. And then we'll see a demo of that working in action with Gloo Mesh. And then we'll have some time for Q&A at the end as well. So let's get started. So the first thing we want to cover is what is EKS Anywhere? For people who aren't familiar, this is our on-premise version of EKS that we released in September of 2021. It's based off the same Kubernetes distro, which is EKS distro, that EKS is built on. So it's meant to simulate the exact experience you have running on EKS on public cloud, but on your on-premise servers. Why it's super useful as well is because we took out any of the requirements with other AWS services. So it can run totally isolated in that scenario where you don't have a connection back to the public cloud. So that would be things like IAM role service accounts or the load balancers. Those aren't a requirement for EKS Anywhere, but you could have those if you want, but you could also run this air gap. So it's a totally open source service, and it's built on open source standards as well. So you can see exactly what the Kubernetes is we run and what patches we put on, and every piece of it all on GitHub. It's bundled with components to accelerate like your launch and getting started. So we put things like Cilium in there as the CNI, Cert Manager to manage like the CA and the cluster, the communication between like the vSphere and your cluster, and then things like management of etcd and all of that we cover for you. Amazon EKS Anywhere provides Kubernetes lifecycle management in your data center on your hardware. And like I mentioned in the last slide, we are offering an opinionated cluster creation and lifecycle management tooling. I'm not going to go over everything that we provide, but like things like OIDC, connection back to the console, enterprise support if you're a paid customer are super useful. And we've had a lot of customers that are trying EKS Anywhere in their own data centers. It's totally free if you want to try it. And if you want to get the enterprise support, obviously you can, there's like a paid license version. And so when people are trying EKS Anywhere, there are sometimes scenarios where they want connections back to their public cloud for reasons like data or other microservices. Amazon EKS Anywhere is built on the open standards and provides a consistent experience across environments. So like we mentioned earlier, it is meant to be a offering of Amazon EKS, but on-prem. So we use the same core primitives under the hood to give you that feeling that you are running EKS, but in your own data center. We use Cluster API to provision the clusters. That isn't what we use for Amazon EKS, but it is what we are using for EKS Anywhere. And that helps give us a consistent experience because we're able to use the different CAPV providers to make sure that the cluster is created in the exact way that it would be on the public cloud. We also have the same operational experience across on-premise and the cloud. So things like getting your information in your console, security, we use all the same patches, all the same observability and deployment tools work. And then the biggest difference would be what hardware you're running on, because on premise you have your own bare metal VMs, VMware, where on the AWS cloud you're using Amazon EC2 or Fargate most likely. But from the operational perspective of managing a cluster, it should feel like the same experience. And that's really what we're going for, is when you go type kubectl, it feels exactly the same as Amazon EKS. Amazon EKS is obviously the most trusted and secure way to run your Kubernetes. It's the best place to run Kubernetes. According to CNCF survey, 65% of organizations choose AWS to run their containers. We run totally vanilla upstream Kubernetes with some security patches put on top. Why this is important is because whenever there's things like API depreciations, we are always following upstream standards. So you can look to the upstream guidance for things like that, in addition to our guidance to figure out how you need to resolve these. We support 4 versions backwards of Kubernetes for security purposes. I mean, we will help you upgrade if you are getting to the point where you are behind more than 4 versions, but it gives you enough time to usually test out upgrades. And especially when you have API change upgrades, that's a big deal. We provide a managed Kubernetes experience for performant, reliable, and secure Kubernetes. Those are our biggest tenets. We do a lot of stress testing and reliability testing and security testing. We have members of our engineering team that work on the SIG security board. So we're always trying to keep security as like our #1 goal in mind when we're building Kubernetes. And then we also are trying now to make operations, administration, and management simple and boring. And so now that we've got the security and performance and reliability really down, we're trying to make your life easier as a Kubernetes admin and take out some of the tasks that provide no value to your company. We call them like the toil tech, right? And so that's really what we're working on right now. So we're going to talk about a scenario now that you have a background of Amazon EKS Anywhere and Amazon EKS. So one's on-premise and one's in your public cloud. And so a scenario that we get really often is people want to have a cluster on-premise and some clusters in the cloud, and they need them to talk to each other. We had one large gaming company, and for their gaming purposes for latency, they were running on-premise clusters in different co-locations across the country, but they ran a lot of their microservices in US West 2 in Kubernetes there. And they needed a way to have these clusters on their co-locations talk back to these clusters in US West 2 because for like different things like authorization or like their client, they had to have the colos talk back to these different microservices. And so in their scenario, we had to figure out a way to create like a service mesh or cross-cluster communication so that these clusters could seamlessly talk between each other. And so this is a common scenario. Things also like data. So if you have all of your databases on premise, or if you have them all in the public cloud, and you're running Kubernetes on edge, you might need them to talk back to the databases, right? So this is becoming a super common scenario as companies are getting more mature in the Kubernetes space, and they're able to run more Kubernetes clusters across the different areas that they work in. So like I mentioned, latency, security, data residency, So what we're seeing is gaming companies, healthcare, financial services, they all have different use case that would require them to run some amount of Kubernetes on-prem. And the majority of them are also AWS customers who already are running in the cloud. And so what we're going to do is we're actually going to be using Gloo Mesh, which is a product by Solo, to facilitate that cross-cluster communication seamlessly here. So here's a diagram of what it will look like. So if you're familiar with Istio, there's like a booking app. And so what you're looking at here is the booking app routes. So you see like the reviews routes and stuff. And so we have the EKS cluster on premise here. And we're using Gloo Mesh to have it talk to another service in the EKS cloud. So you have the review app needs these reviews to talk to the rating microservice. So this is exactly like our gaming company scenario. And so the services don't know that they're talking to another cluster. They're just trying to talk to, service dot namespace dot local, right? And so with Gloo Mesh, you can make this a really seamless communication where your clusters are able to talk across to each other without having to know that they're talking to each other. So this is kind of like a diagram to keep in your head here. And this is what the end state is going to look like here from our demo that Lawrence is about to show us. So I'm going to go over it so we can watch the demo here.
Okay, so let's take a look at how we can use Gloo Mesh to connect your Amazon EKS Anywhere cluster to an Amazon EKS cluster running in the public cloud. For this demo, we'll be using the standard book info example application from Istio, which is a microservice-based app that has a UI front end called the product page, which we can access through a browser that then calls a handful of microservices behind the scenes. So there are 3 review services that are called, a detail service, and then V2 and V3 of reviews we'll call the rating service. So we're going to take this application and deploy it to EKS Anywhere and EKS. So our EKS Anywhere cluster, which will be running on my laptop, is going to contain the majority of the application. So we'll have the product page, all 3 of the review services, and the detail service. And then to simulate the cross-cluster, cross-cloud connectivity, we'll have the rating service running on a EKS cluster running called public cloud, running in the public cloud. And then we also have a management cluster where we'll install Gloo Mesh. This will also be running in the public cloud. And this will be responsible for configuring and managing these 2 workload clusters. So let's go ahead and get started. I have the script on the right is an actual script that can be run to do all of the steps that we'll be doing. But for the demo, I'll just copy and paste and kind of talk over the steps as they happen. So the first thing is I'm setting up some environment variables that will be used throughout. Then I would create the actual EKS public cloud clusters. I did that ahead of time just to save some time. But this is the command these are the commands that I use. So basically EKS create cluster, kind of just standard EKS clusters. And kind of just to show where we're at right now with those pre-provisioned clusters, we'll take a look at the context and the deployments available. So I have 2 kubeconfig contexts, cloud and management. And on the management and cloud clusters, I only have, the only deployment running is core DNS. So basically they're just bare install clusters. So next we're going to actually create the EKS Anywhere cluster. This is just following the documentation. First, I'm going to use the EKS Anywhere plugin, EKS Anywhere plugin to generate a config file. And I'll be using the Docker provider since this is going to be running locally on my laptop. And then I'm going to use that config file to actually create the cluster. So we'll go ahead and kick that off. This will take a little bit of time, so we're going to go ahead and fast forward to when the cluster is created and ready to go. Okay, so now our EKS Anywhere cluster is now ready to be used. Basically, the cluster has been created. And in order to use it, I'm going to actually take the kubeconfig file that was generated as part of the bootstrap process and add it to my kubeconfig environment variable so that I can use it with kubectl commands. And then I'm going to rename the context just to match the variables that we set at the beginning. So now let's go ahead and just check, make sure that everything is good on it. So we're going to get the deployments and all the namespaces on that cluster. And you can see there are several kind of infrastructure related deployments, and they're all ready. So this cluster is good to go. So the next step we're going to do is install Istio on the Cloud and EKS Anywhere clusters. In order to do that, I'm going to use the Istio CTL CLI tool. And in order to use it, I got to add it to my path. And then I'm going to basically, I have two config files that are, this Istio operator.yaml and then the Istio operator EKSA YAML. Those are basically the config files for installing Istio. I'm taking them, doing things like replacing the cluster name to be correct. And then I'm using istioctl install, which will take that config file, translate it into a set of manifests, and then apply those manifests to the cluster. And when that's done, the end result is Istio will be installed. And so in this case, the cloud cluster looks like the install has just finished. So I'm going to go ahead and kick off the install for the EKS Anywhere cluster. And while that is running, I'm going to get the next commands ready. So basically, once the installation is complete, we'll go ahead and actually check the pods in the Istio system namespace, which is kind of the default namespace for Istio, make sure that the pods are up and running. And so as this is almost done, and actually, since it just will complete, we'll go ahead and do it one by one. We'll check the cloud cluster first. Okay, so let's check the cloud cluster. And as you can see in the Istio system namespace on the cloud cluster, we have an east-west gateway, an ingress gateway, and Istio-D, which is the control plane for Istio running, and they're all ready to go. So now let's check the same thing on the EKS Anywhere cluster, and same thing. So all three pods are ready. So now let's actually deploy our book info application. So if you remember on the cloud server or on the cloud cluster that's running in the public cloud, we're only going to deploy the rating service, and then we're going to deploy the rest of book info on our EKS Anywhere cluster. So let's go ahead and do that. So first thing I'm going to do is label the default namespace, which is where I'm going to deploy the application. In this case, on the cloud cluster, I'm labeling the default namespace with Istio injection enabled, and then creating the various components necessary for the rating service only. That label is there because that is what tells Istio that as pods are created in this namespace, we want to inject the proxy as a sidecar. So the end result is that the pod spins up with the application as well as the proxy. And then we're going to deploy the rest of the application other than ratings on the EKS Anywhere cluster. So that's created. Let's go ahead and check the pods in cluster 1, which is the cloud cluster. So this should only be the ratings service. And you can see that the ratings v1 pod is up and running as of 35 seconds ago, and it's 2 of 2 containers are ready. So the ratings container and the sidecar proxy are ready. And then now let's double check the EKS Anywhere cluster. And this has all of the rest of them. We have the details, product page, and the 3 versions of reviews. Those are still initializing. If we run it again, we should see some, so reviews v1 is now running 2 of 2. While these spin up, we'll go ahead and move on to the next step. So next, we're actually going to install Gloo Mesh, and we're going to do that on the management cluster that's also running in the public cloud. So we're going to install that with Helm. And again, this is going to install the management plane essentially on the management cluster. And again, the management cluster is going to manage the 2 workload clusters. So once we have the management plane installed, we need to register our clusters. And when we have that completed, we'll be able to use Gloo Mesh and the Gloo Mesh APIs to do things like expose the application and then also set up the cross-cluster networking that we want to set up. So let's go ahead and check the pods before we move on. The book info pods on cluster 2. So those pods are up and running, 2 of 2. And then now let's check the pods of the Gloo Mesh installation on the management plane, on the management cluster. And we can see that we have 4 pods, for example, the management server and the UI, and those are ready and running. So now we'll actually register the clusters that are necessary. So Cloud and EKS Anywhere. And so the first thing we'll do is create a custom resource called the Kubernetes cluster. This is essentially telling the management plane that these clusters are registered and will be able to basically be managed by the management plane. And so we created one for the cloud and we created one for EKSA. So now that those are there, we can actually bootstrap the connection. So we're going to install a agent, the Gloo Mesh agent on these clusters. And that's what will actually have the communication with the management plane. So we need to get the management server address, which is called the relay server address. This is just a load balancer service on the management cluster. And as you can see, we have this standard kind of AWS load balancer domain name. And so this is what we'll use to register the agents. As we install them, we'll use this address to connect and kind of set up the initial connection. And speaking of that initial connection, the connection is in mutual TLS secured. In order to bootstrap that though, we need to set up some secrets on the workload cluster so that the agent can use them basically to bootstrap the connection. It needs to have some credentials so that it can establish the correct connection. And so we copied them over from the management plane to the workload cluster. And so we can kind of confirm that those secrets were created successfully. And you can see we have the relay identity token and the relay root TLS. So now we can actually install the agent. In this case, we'll do it on the cloud cluster. And it will use these secrets and the relay address to actually establish that connection. And so this is just a simple Helm install. And as you can see, we set, for example, the server address to the server address of our load balancer. And so now that that's installed, we can check the pods in that namespace and we should see that the agent is running and ready. And so now the agent in the cloud cluster is talking to the management plane, and then we'll repeat the same process, creating the secrets and installing the agent for the EKS Anywhere cluster. So we'll create the secrets first. We're going to make sure that they were created successfully, and they were, identity token and root TLS. And then we will actually install the agent on cluster 2, our EKS Anywhere cluster. And so now that that's done, we're going to actually check the pod. This one might be a little quick. Yeah, so the container's creating. We'll give that a second. And while that's finishing, I'm going to copy over the next commands. We'll check one more time. Okay, so the agent's running on EKS Anywhere. So the next step is kind of the last kind of setup step, and we need to create what's called a workspace. So in Gloo Mesh, the workspace concept kind of defines tenancy rules. So maybe a team shares a workspace and all of the services owned by the team are in a workspace, or maybe it's bigger than that and you have like an organization that shares a workspace. Either way, for our purposes, we just want everything to be part of a single workspace. So this workspace that's being created is a very generic one. That means any any cluster and any namespace in that cluster will be part of the same workspace. So to kind of see that in action, we can actually go ahead and check out the Gloo Mesh UI now that everything should be ready to go. So I'm going to go ahead and port forward to the UI, and then we can check it out in the browser. So if we come here, localhost 8090, you'll see the Gloo Mesh UI. Let me refresh it. So on the right, you can see the clusters. We have a cloud cluster and an EKS cluster that are registered. You can see some information such as the number of nodes and so on. You can also see that the Istio installation was auto-discovered. And then in the workspaces on the left, we only have one workspace that we just created. And that workspace has 2 clusters that are part of it, which are our 2 clusters, 14 namespaces between those 2 clusters, and 4 gateways. We could also see some more detail here. Kind of, we can drill down if we wanted to get some more details. But this kind of confirms that everything is wired up and we're good to go. So now we can actually start configuring our application so that we can have first access the application and then configure the network connectivity that we want. So the first thing we're going to do is actually establish a root trust, a shared root trust across both clusters. This is a simple one, a self-signed example where what we're telling Gloo Mesh to do here is create a self-signed CA, distribute intermediate CAs to the workload clusters so that the Istio pods on each cluster can communicate mutual TLS regardless of which cluster it's running on. In other words, when we call that rating service running in the public cloud, we want that to be an east-west service call, just a service-to-service call that uses mutual TLS. And in order for that mutual TLS to work, both clusters have to have a shared root of trust. And that's what we just did by creating this policy. It's also going to restart the pods in this kind of POC example or demo example, because we need the workloads to pick up that UCA. And so let's check that the pods have restarted correctly. We will check. So you can see on the cloud cluster, for example, the Istio pods are up and running as of 20 seconds ago or so. The ratings pod was just coming up as a restart. On the EKS Anywhere cluster, the Istio pods are restarting and the workload pods are restarting. So we'll actually run that one more time. And we can see that now everything is up and running and has restarted recently. So they should all have kind of that new shared root. So let's actually be able to access our application. To this point, we haven't even tried the virtual, we haven't even accessed the application. And to do that, we're going to create a virtual gateway. And so what the virtual gateway does is essentially we're telling Gloo Mesh to set up Istio config that will allow us to access the product page application on the EKS Anywhere cluster. And so the end result of this is that we can now, I'm going to open up a new tab. And what we can do is I'm going to get the EKS Anywhere config working in this terminal real quick. And then I will be able to port forward to the ingress gateway on the EKS Anywhere cluster. And now I can access product page. So if I go to the browser and hit localhost 8080/product page, you can see that I now have the book info application rendered out. You'll also notice that this rating service is currently unavailable. So that means that on this request, we hit one of the reviews versions that talks to ratings. And since there's no communication right now between clusters, ratings cannot be accessed. So if we refresh it again, in this case, this is reviews v1, which doesn't talk to ratings. But if we refresh it again, we should see, now we're seeing the rating service unavailable. So basically the application's working, it's trying to talk to ratings, but ratings essentially doesn't exist at this point. So now we can hook up and set up the cross-cluster communication so that when the product page or the reviews applications, the reviews services, try to access the rating service, that will happen over the mutual TLS connection and go to our cloud cluster where ratings is actually running. So to do that, we're going to set up a few resources. The most important one is this virtual destination, which, as the name implies, is we're basically creating a virtual destination in our mesh that can be called from any cluster that's part of the mesh. And when that virtual destination is accessed, we will set up the kind of under the cover routing rules that are necessary to get the request to where it needs to go. So in this example, when cluster EKS Anywhere, when the reviews applications on that try to talk to ratings, we're going to go through the east-west gateway and make a mutual TLS connection to the cloud cluster, which has ratings running on it. So let's go ahead and go back to our application. Now that the virtual destination's in place, we refresh this a few times and you can see immediately we now have black stars, meaning the rating service is working. And so if we refresh this a few more times, we can see that we're getting all of the versions of reviews and all of the versions that talk to ratings, we're successfully getting stars back because that communication now works. So one of the other interesting things we can do, let me just refresh this a few more times, we can go back to our UI and we can actually see this traffic happening, for example, on our service graph. And so you can see here that we have the EKS Anywhere cluster with the majority of the applications running on it. And then in this case, this is seeing that reviews v2 is talking to ratings in the cloud cluster. Let me refresh it a few more times so we can see all of the versions. And then let me go ahead and change this a little bit. And what I want to do. Okay, so we now have a service graph that shows basically what we wanted to set up in our architecture diagram. So we can inspect the traffic that's flowing through and we're getting metrics that can help drive the service graph that shows that requests are coming through to the product page. Details v1, reviews v2, and reviews v3 are running on the EKS Anywhere cluster. And then reviews v2 and reviews v3 are calling rating service running in the cloud. And so just with a few configuration files, we have been able to establish connectivity between a unified EKS environment where we have EKS Anywhere running on our laptop, And then we have communication with an EKS cluster running in the public cloud. So that's it for the demo. Thank you.
All right, Lawrence, thanks for that awesome demo. And hopefully it gives everyone a better idea of how powerful Gloo Mesh can be with facilitating that cross-cluster communication. And this doesn't just have to be for public cloud and on-premise, like our use case. This could be any Kubernetes clusters anywhere, it seems like, right? So now that we've kind of went over what we were trying to talk about today, if there's any questions you have, feel free to add them to chat and we can answer them and right now. So, well, thank you for attending the talk today. And if you want to learn more, we have a GitHub link here for the demo that Lawrence showed. It's L Gadban, which is his GitHub name, EKS Gloo Mesh. So feel free to check it out and try the demo out yourself. This will also be included in the slides at the end. So if you want to grab these off the slides, you're more than welcome. Thanks everyone for attending and joining the talk today.